Hi and welcome to Math Plus Everything Journey. Today we have two Pythagorean theorem problems that we're going to look at. One is when you find the hypotenuse and one is when you find the other leg. Let's dive in. So this problem states, one of the legs of the right triangle measures 7 centimeter and the other leg measures 15 centimeter. Find the measure of the hypotenuse, and then it's necessary round it off. So in this problem, it says one of the measure is 7 centimeter of the leg, and then the other leg is 15 centimeters. So we are finding the hypotenuse. Where's the hypotenuse located in this problem? So we have one leg, 15 centimeter, another one, 7 centimeter, and your hypotenuse is across from your right angle. So this is your hypotenuse. Okay. So how we find the hypotenuse? We use the formula a squared plus b squared equals c squared. A squared is your leg plus one of the other leg is equal to the hypotenuse. So one leg square plus the other leg square is equal to the hypotenuse. So I'm just going to fill out this formula because I already know the information. I already know what one leg is and I already know what this other leg is. But what I don't know is what the hypotenuse is. So that's what we're going to solve for. So let's go. What is our a square? 7. So our a is 7 square. Plus, what is our b? Our b is 15. So we're going to have 15 square. And that's going to be equal to c square. We do not know what c square is as yet. We have to solve to find. We know what our a, again, we know what our a is. Our a is 7. And we have 7 squared plus 15 squared. Okay, so where does these numbers come from again? Each leg, and it's stated in the problem. Okay, so let's go ahead. 7 squared is 7 times 7. So 7 squared is 7 times 7 plus 15 squared is 15 times 15 equal to c squared. I'm only doing this step because there's a lot of students that don't know what 7 square is. Also, you can put it in a calculator. Okay, so 7 squared is 7 times 7 and 15 squared is 15 times 15. So 7 times 7 is going to equal to 49 plus 15 times 15 will give you 225, and that's going to be equal to 2 squared. We're not done yet because we have to add 49 plus 225. So when we add 49 plus 225, we are going to get 274, which is equal to c squared. So we are asked to find the hypotenuse, which is c. So we have this in squared. So all we're going to do is take the square roots of both sides. We're going to take the square roots of both sides. So take square root of both sides. So when we take the square roots, we're going to take the square roots. So we know when we take the square root of the square, it cancels out, so it leaves us with c. And the square root of 274 is approximate, not equal to approximately 16.6. You could, for the radical, you could figure this out by doing prime factorization. Or if you're allowed to use a calculator, you could go to your calculator. And in your calculator, oops, let me clear this out. In your calculator, you could put your square root symbol, and then you could put 274. and enter. So when you enter, you get 16.55294,536, but it asks you in the problem to the nearest tenth. So to the nearest tenth is 16.5, and the one next to it is 5, so we're going to do 16.6 when we round it off. Okay, so there we go for this problem. So let's do the other one. Put this aside and let's look at the other problem. So in this problem, we have to find one of the leg. So in order to find one of the leg, we use the Pythagorean theorem again. So again, the formula is a squared plus b squared is equal to c squared. So let's go ahead. A squared, we have nothing for a squared, so we're going to rewrite our a squared. Plus our b is 20, so we're going to write 20, and don't forget to put your squared, is equal to c squared. Now we have our c squared, we have our hypotenuse, right? And remember, hypotenuse is right across from the right angle. So our hypotenuse is 25, so it's 25 square. So let's solve this. We know a squared is a times a, which gives you a squared. I'm going to bring back down my a squared because I'm going to solve to find the leg a. Then I have plus 20 squared is 20 times 20, and that's going to give us 400. And 25 squared is 625. 25 squared is 25 times 25, which is 625. So we're here and we want to isolate a. We want to find one leg, which is a. So we have a squared plus 400 is equal to 625. So what we're going to do, we're going to subtract 400 from both sides of the equation. Why are we subtracting 400 from both sides of the equation? We want to find one leg, which is a. So in order to do that, we have a plus 400. We have to use the inverse of it to cancel it out. So here we go. I'm going to bring back down my a squared. My positive 400 and my negative 400 cancels out. I have 625, and I'm going to take 400 from that. So that's going to leave me with 225. So now I have a squared is equal to 225. There's one more step because I just need a by itself. In order to do that, I am going to square both sides, square root both sides. What you do to one side, you have to do to the other. So when I square root both sides, the squares cancels out. So I'm left with a is equal to the square root of 225 is 15. So that's our final answer. So we know that one leg is 15. And there you have it. Don't forget to subscribe, like, share, tell a friend to tell a friend. And I'll be in the next video. Thank you for your support. Bye.